Problems involving radicals. Our objectives. At the end of this presentation, you should be able to solve problems involving radical expression. Let's start. Some of the problems involving radicals are problems applying the Pythagorean Theorem and the distance formula. There are also formulas used in the field of science where radicals are involved. Example: a ladder 25 feet long is leaning against the wall. If the base of the ladder is 7 feet from the wall, how high up the wall does the ladder reach? So as we represent this, there will be a wall and there will be a ladder leaning against the wall. And the measurement or the height of the ladder is 25 feet. If the base of the ladder is 7 feet from the wall, so from the base to the wall is 7 feet, we want to find out is how high up the wall does the ladder reach. If you notice, we're actually forming a right triangle. This is a right triangle since it has a right angle. So to solve for a right triangle, we will be using the concept of the Pythagorean Theorem. So in this given triangle, this is 25 feet and this is 7 feet. So the Pythagorean states that the hypotenuse or the longest side, which represents as C, is equal to the square root of the adjacent side, which is represent as A, plus the square of the opposite side, which represents as B. Therefore, if we want to find for the adjacent side, the formula is equal to A is equal to the longest side, which is the hypotenuse, the square of the longest side, minus the square of the opposite side. If we want to find for the value of our opposite side, so that will become B is equal to the square root of the longest side, which is C, or the hypotenuse, minus the square root of the adjacent side, or A. Now, in this given example, how to identify where is the adjacent, the opposite, and the hypotenuse. So the first thing you should do is to find for the right angle. So the right angle in this given is this. The opposite side of the right angle is the hypotenuse or C. The opposite side of the hypotenuse or C is our opposite side. And what left will be our adjacent side. Now let's have our given. In this given, the hypotenuse is 25 feet. So I can write that C is equal to 25 feet. Next is A, which is the adjacent side, which is 7 feet. Now our unknown, or we want to find, is actually the height of the wall, which represents as the B or the opposite side. Since the unknown is B, we will be using the formula B is equal to the square root of C minus the square root of A. So let's substitute. So we got B is equal to the square root of 25 squared minus 7 squared. So let's simplify. B is now equal to the square root of 25 squared is 625 minus, we got 49. So subtracting 625 by 49 will give us a difference of 576. Now let's simplify the square root of 576. So the square root of 576 is 24. Therefore, the height of the wall is 24. Since the unit that we use is feet, so this is also 24 feet. So let's have the next example. A formula used to determine the velocity v in feet per second of an object after it has fallen a certain height, neglecting the air resistance, is v equals to the square root of 2gh, where g is the acceleration due to gravity and h is the height of the object has fallen. On Earth, the acceleration g due to gravity is approximately 32 feet per second. Find the velocity of a person after falling 5 feet. Round off your answer to the nearest tens. This example is an example of the application of science using the radicals. So our formula given is the velocity is equal to the square root of 2gh. Now take note, we are neglecting the air resistance. Now what are the given? G represent as the acceleration due to gravity and height, and h will be the height of the object has fallen. So in this case, on Earth, the acceleration g due to gravity is actually approximately 32 feet per second. And the height is 5 feet. Now, our unknown is, since the question is find the velocity, so the unknown is the velocity. So we'll just simply use the given formula. So we got v is equal to the square root of 2gh. Substitute for the given value. So v is equal to the square root of 2 times 32 times 5. Now remember, if there will be no operation between the given terms or variable and numbers, the operation will be multiplication. So let's solve. V is equal to the square root of 2 times 32, that is 64 times 5. V is equal to 64 times 5 is square root of 320. Now, since our answer should be written in decimal, so we need to make the radical into decimal. So the velocity now is 17.9 feet per second. The point 5 and 4 lies on a circle. What is the length of the radius of this circle if the center is located at 3 and 2? So you can use a Cartesian coordinate plane to draw a circle. Okay, but for this case, I will just simply draw a circle. And let's say this is my point 5 and 4, and the center, which is 3 and 2. Now we want to find is for the length of the radius. Now take note, class, that the radius is a line from the center to any point of our circle. Now to find for the length of the radius, we will be using the distance formula. So the distance formula states that d is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. Now we have two ordered pair. We have 5 and 4, and we got 0.3 and 2. Remember, the ordered pair composes of the x and y value, or the abscissa and the ordinates. Since we involved two ordered pairs, so we can rename the given ordered pair as the first ordered pair as x sub 1, y sub 1, and the second ordered pair as x sub 2, y sub 2. Now let's write the given. The given are x sub 1, which is 5, x sub 2 is equal to 3, y sub 1 is equal to 4, and y sub 2 is equal to 2. Now again, the unknown is the length of the radius. To find for the length of the radius, we will be using the distance formula. So we can now solve. So we have d is equal to the square root of the quantity x sub 2, which is 5, 3, so we got 3 minus 5 squared plus 2 minus 4 squared. Solve. So 3 minus 5 is negative 2, so that will become negative 2 squared, plus 2 minus 4 is negative 2 also. And let's square it. Now simplify. Negative 2 squared is equal to 4, plus negative 2 squared is again 4. So let's add the given. So that d is equal to the square root of 8. Now simplify square root of 8. So our d is equal to 2 square root of 2. Therefore, the length of the radius is 2 square root of 2. Thank you.